Good morning, students. Now the next chapter, that is circle. First of all, you know what is circle. The circle is collection of the points which is equidistant. These points are equidistant from that point. Is known as circle. And this one divides into three parts. One is outside. If you take this region, that is exterior. If you take this one, interior. If you take this one, all circle. So the plane on which the circle lies divides it into three parts. Outside of it known as exterior, inside of it known as interior, and second one is on the circle. If you take that fixed point, the distance from fixed point to the circle is known as radius. If you take any 2 points, take any 2 points, so P and Q. If you draw a line, this line is known as chord of the circle. If this chord passes through that point O, which is fixed point of that one, and from this fixed point the distance of all the points lies on the circle are equal, and if you draw that line which passes from the fixed point, then it becomes a diameter. So here AB is diameter and PQ is chord. Now if you take that one, this boundary is known as circumference of the circle. Now if you take that length on the circumference, that is known as arc, ARC. If this part is smaller than the rest part of the circle, then this becomes minor arc, and this one becomes major arc. So this arc made on which part of the circle? That is on the circumference of the circle. This one is chord. So chord and that arc combinedly make an area. This one is known as segment. So here how many segments? 2 segments. One is this one, another is this one. If in these 2 parts the smaller part is known as minor segment, and the bigger one is known as major segment. This one is a circle, this one is the center. If we make two radius, and these both are equal as both are the radius, and this one is the arc, so here also make an area. This one is known as sector. So the raised part is also a sector, as this part made by this circle and this arc. So smaller is known as minor sector, and bigger one is known as major sector. So what we have learned first is, what is circle? A collection of points which are equidistant from a fixed point. The distance from that fixed point to that circle is known as radius. If you take any 2 points on the circle, and if we join these 2 points, this becomes a chord. If this chord passes through the center, then it is known as diameter. Now, if you want to divide that circumference of the circle, then take any 2 points on the circumference. The portion made by these 2 points, if this one is smaller than the raised part, then it is known as minor arc. The raised one is known as major arc. Next one, segment. Segment made by chord and area made by chord and arc, that is segment. If this one is smaller than the raised part, then it is known as minor segment, and the bigger one is known as major segment. Last one is sector. Area made by radius and arc. If this one is smaller in respect of raised part, then it is known as minor sector, and the raised one is known as major sector. Now exercise 10.1. The center of a circle lies in of the circle. So this one is the circle. This one is the center. So now here is the question, center of the circle lies in which portion? That is interior. So answer is interior of the circle. A point whose distance from the center of a circle greater than its radius lies. This one is the radius, but that line is greater than its radius. So greater than its radius, that line must be outside of the circle. So greater than its radius lies in outside, say right, exterior. Exterior of the circle. The longest chord of a circle is of the circle. The longest chord that must pass through center. So, a chord which passes through the center of the circle is known as diameter. So, here answer is diameter. An arc is a when it ends are the ends of a diameter. So any portion on the circumference of the circle that is known as arc. So end points of a diameter. So this one is the diameter, end points, one point is here, another point is here. So this one is the arc. So this part divides the circle into two. So this one is known as semicircle. Semicircle whose end points are on the diameter. Segment of a circle is the region between an arc and of the circle. So arc and this arc and chord or of the circle. So chord of the circle. A circle divides the plane on which it lies in how many parts? So this one is a circle lies on that plane. It divides 1, 2 on the and third is interior. So how many parts? 3 parts. So answer is 3. Line segment joining the center to any point on the circle is a radius of the circle. The lines are made joining the center to any point on the circle. Center to any point that is known as R. So that one is matched with that statement. So here is true. So number 2 is circle has only finite number of equal chords. Pause. This one is chord, This one is chord, this one is chord, this one is also chord. Passes through center. So equal chords, they are not equal. So that statement is false. Number 3. If a circle is divided into 3 parts, three equal arcs, each is measured arc. If 3 equal arcs divided into, so each is measured arc, because in that case major and minor both are present, so each not a measured arc. So statement is false. A chord of a circle which is twice as long as its radius is a diameter of the circle this one is radius and this one is diameter. So diameter is double of the radius and the statement is still the same thing. Double means D2R, double of the radius is diameter, twice as long as the radius, so that statement is true. Sector is the region between the chord and its corresponding arc. This one is the sector. What is told that one chord, but in this figure both are radius, so it is not a chord. Therefore, the statement is false. A circle is a plane figure. This one is circle, this one is a circle, this one is also a circle. So, all these are plane figures, so statement is true. Theorem: equal chords of a circle subtend equal angles at the center. Where two chords are there, AB and CD, we sustain triangle AOB and angle COD at center. These AB and CD are equal chords, and so you have to prove that one. This obtain equal angles at the center. Suppose given a circle, center O and R is the radius, in which chord AB is equal to chord CD. To prove angle AOB is equal to angle COD. Now prove in triangle AOB and triangle COD, taking this two triangle, OA is equal to OD. OB equal to OC, same radius of the circle. AB equal to CD, that is given as their equal chords given. Therefore triangle AOB congruent triangle COD, all are sides by SSS congruency property. Therefore angle AOB equal to angle COD by CPCT, corresponding parts of congruent triangle. So we have to prove this one. So right. Proved. So by SS congruency property, these two triangles become congruent. Therefore, angle OB equal to angle COD by CPCT. Congruency.